And hello everyone. This is our team members, and we are group one. And today we are focused on the cooling system. So we want to share some ideas here. And our conceptual idea comes from a green city, and we think that our whole plan is focuses on ecological and sustainable living and architecture, because it has been demonstrated that nature and green spaces could promote human health and well-being, as well as mitigate global warming. So that's why we choose this topic. And
Okay, so we just had ideas for our rain gardens. We thought that rain gardens are a great way to like filter out the stormwater, helps with stormwater runoff, and it also helps problems with drainage and flooding. And we also wanted to implement green roofs, which basically is a layer of vegetation that lies on top of a roof, and it usually needs little to no maintenance, and it provides help shade and reduce temperatures as well. And we also have the idea to implement green walls, which are basically vegetation on a vertical wall, and that is where it provides thermal insulation, and it helps reduce noise pollution and as well as purifying our air.
yeah, as we mentioned before, we want to harness the power of greening into our environment. So that's why we come out the idea of vertical green building. And sorry. Yeah, so how to realize it? And we think maybe we can use the low-tech decades that is made of wood and panel glazing here, because it could both save energy and costs. And these materials are highly insulated with integrated sunscreens, and this layer of planting shadows in the terrace in the summer while allowing warming sun through in the winter. And in addition, we can employ the hydroponic irrigation system here, and the diverse climbing plants, as you can see in the picture. And the use of pesticides is not required because the plants are fostering natural pollination. So, and this is the energy saving parts, because the vertical green buildings are not just an organic donation to people's the neighboring units, but also provide a natural ventilation throughout the complex, which is a healthy alternative to common mechanical cooling. And the natural air flow circulation prevents the building from the overheating and saves more about 16% of the energy, which results in a lower carbon footprint for the whole development. And this is the benefits.
So some benefits that come with this, it comes a lot more with just than just cooling the facility. So for one, it can reduce greenhouse emissions, and it can assist in improved water quality, same with improving stormwater management, and reduce energy consumption per household and building, because it helps with insulation. And I know that earlier we talked about how transporting these materials to the habitat is a big issue. And so with this, you can just have seeds, which are very small, lightweight, and transport them. And it can also improve the air quality, provide some sound insulation, so there's a lot less like noise going on. And it also just looks pretty. And so how it helps with cooling. So plants do a number of things like evapotranspiration, which is basically whenever it's too hot for the plant, it will cool itself. By cooling itself, it takes in heat from the outside, produces water, which also reduces the heat, cooling the air surrounding it. And then with shading, so if we have like a lot of pavement and metals, providing shade can significantly reduce the temperature of it. And then it also reduces heat through photosynthesis. And then with insulation, it helps reduce the amount of heat passing out of the building. So then you can spend less energy and electricity on changing the temperature inside buildings or houses. And it can also decrease emissions. You can have it in conjunction with your HVAC systems so that you can still have that providing ventilation and air conditioning, but it's removing those excess emissions.
Yeah, that's all.
So you mentioned that transporting seeds could reduce building cost. But the mass of plants doesn't necessarily come out of thin air. It comes to nutrients that they pull up. So you still would have to transport the necessary materials to actually fertilize the plants and like give them like the mass they need to get bigger. But I still feel like it might be cheaper because you could easily store fertilizer and stuff in smaller packages, whereas with construction materials, it's got to be long.
That's an excellent comment and question. And that's one of the things we're addressing with the small prototype design. We're looking at a vermiculture system, which translates biomass into nutrient solution by adding the worms that can decompose organic matter. So that's how we create healthy soil from nothing. So at the beginning, maybe you grow plants out of seeds, and those plants then create biomass. And then gradually you can turn the biomass into dirt, right? And then the seeds from those plants then create more plants, So gradually, yes, you can build up soil. Yes, you can have more plants over time. Does that answer your question? So I think integration with the waste management part, like integration with folding the solid waste from humans and animals, back into the food production or plant production system is the key. Because we can't afford carrying fertilizers up to space, right? But fertilizers, humans and animals are fertilizers.
Okay.
Simply put, we just need to calibrate their solid waste somehow, separate the urine from the manure. In fact, in the eco district in Germany, most of the companies have these systems where they use separation toilets to collect urine without the feces, and their employees will just go and collect the urine with the jar before they go home to fertilize their plants. So when we begin to think about integrating waste into resources, right, that could facilitate thermal management or energy reduction, right, I think it's crucial to think in a interdisciplinary way beyond the system. Did that answer your question?
Yeah.
Okay, cool. Excellent. I'm glad that we didn't just think about, what are the machines we're going to use to produce energy? How can we get more energy? We're actually thinking about how can we do more with less, right? How can we minimize energy demand, right? That's also a very important part of